All right, we are going to look at writing and graphing in intercept form. So as a brief review, we have learned writing and graphing functions in standard form. That's ax squared plus bx plus c. And that one, right, our c value will tell us where our y-intercept is. Then we also have our vertex form, which is a times x minus h squared plus k. And vertex form is helpful because that tells us our vertex, which is at hk. And now we're going to look at intercept form, which is a times x minus p times x minus q. And this may look familiar to you because this is basically our factored form of a polynomial. Now, the requirement here is that a is not equal to 0, otherwise our entire function would equal 0. But the nice thing here is that in this form, our x-intercepts would be at p0 and q0. Right? If we were to look at this, that would be like solving for the zeros of our function. And if we had something that was written in the form 2 times x minus 3, x minus 7, right? We can see that if we were to solve these for 0, x minus 3 equals 0, and x minus 7 equals 0, you're going to get x equals 3 and x equals 7. So you can see that p and q represent our x-intercepts. The other thing to note here, right, our axis of symmetry is always going to be halfway between our x-intercepts, right? So the easiest way we can calculate that is using this here. X is equal to p plus q divided by 2, right? So if you had a p value of 0 and q was at 7, right? You add those together, you get 7 and divide that by 2, and you would have 3.5. So it would tell you that your axis of symmetry, and therefore your vertex, would be at x equals 3.5. Now let's practice graphing in intercept form. So the first thing we want to do is graph our x-intercepts. Then again, we can find our axis of symmetry and then use that x value for the axis of symmetry to graph the vertex. So let's look at this one here. We have f of x equals negative x plus 1 times x minus 5. So that negative there in front could represent negative 1 as our a value. So again, if it is written in the form x minus p, x minus q, right, then that means our p value here, since this is plus 1, then p is going to be negative 1, and q would be 5. So that means we're going to have x-intercepts at negative 1, 0, and at 5, 0. Didn't quite give myself enough room there, but that would be 5. Okay, and then we want to substitute x into our equation after we can find that, right? So remember, our axis of symmetry needs to be halfway between p and q. So we can find that by adding negative 1 plus 5 and dividing by 2. Negative 1 plus 5 is 4, and 4 divided by 2 equals 2. So our axis of symmetry is going to be at x equals 2, which means our vertex will be at x equals 2. And now we substitute that into our equation. So f of 2 is equal to negative 2 plus 1, 2 minus 5. So 2 plus 1 would be 3, and 2 minus 5 would be negative 3. So then we have 3 times negative 3, which is negative 9, and negative 1, or negative 9, would equal positive 9. So our vertex here would be at 2, 9. Now, since we have 3 points, we can graph our parabola. All right, now let's look at another one. Now this time, our function is written as f of x equals 2x squared minus 8. So first we want to rewrite this in intercept form. So all we have to do is factor it, right? So if we look at this, we have a common factor of 2. So if we factor out that 2, we get 2 times x squared minus 4. And then you might notice this is a perfect square. So we can actually factor that x squared minus 4 into x plus 2, x minus 2. Right? And if you don't recognize that perfect square pattern, that's okay. You can always set up your diamond here and solve that way, knowing that it needs to add to 0 because we don't have a bx value and multiply to negative 4. And that would give you your negative 2 and your positive 2 right there. All right, so now we've got it written in intercept form, and we can go ahead and graph it. So again, intercept form would be a times x minus p, x minus q. So again, because we're adding here, that means our p value is going to be negative 2. So we have an x-intercept at negative 2 and an x-intercept at 2. Again, we can find our axis of symmetry using x equals p plus q divided by 2. So that's going to be negative 2 plus 2, which is 0. And 0 divided by 2 is 0. So our axis of symmetry is going to be the y-axis. So now, substitute x equals 0 into our function. Zero plus 2 is 2, 0 minus 2 is negative 2. So 2 times 2 is 4, and 4 times negative 2 is negative 8. So our vertex would be at negative 8. And again, we can graph.